In this video we shall talk about physical modeling objectives. The physical level is the richest with details, so we absolutely have to take into account technical aspects of our DBMS. And in addition to all those ideas we've already mentioned on previous levels, we have to think about triggers, storage routines, storage engines, encodings, permissions, and so on and so on. This is the official definition of physical modeling level, so you may pause the video and read through this text, but we now shall discuss the main idea. So the main idea, the main objective is to carefully think over and write down any specific detail about our database. To achieve this goal, we have to take into account DBMS specifics, use top-down and bottom-up approaches, and think about representation form. There are a lot of specifics for any DBMS, so we have to read manuals, analyze, experiment, and here we cannot ignore any technical detail. So manuals is the best source of information about that special technical details. Top-down and bottom-up approaches are still with us, and we still have to take both ways to make our database both subject matter adequate and application level usable. So here we concentrate on that thing and still remember about subject matter. Hopefully you remember that on previous levels we've used texts, lists, and UML schemas or other schemas like representation form, but unlike with two previous levels, here we have no traditional approaches because there are a lot of DBMSs and each DBMS has some specifics. So we have no traditions, we have no rules here, but still we have to think carefully and select best representation form, and we'll see some examples in the next videos. Now we'll discuss main ideas to start with. We have to think about access permissions, encodings, storage engines, indexes, and some DB or DBMS settings. There are two main approaches to access permissions. The first is single user mode. Why is it single user? Because our application uses one login and one password to connect to DBMS and work with the database, and then each user provides his own credentials, and that credentials are stored in the database. So DBMS cannot control each user separately. This is the easiest approach, but it has disadvantage due to this lack of control on DBMS side. The second approach is multi-user, because each user has some credentials and that credentials are used to authorize the user on DBMS level. The application only passes this information to DBMS, and then DBMS controls who and what can or cannot do with the database. Of course, you'll have to create all those users on DBMS level and manage their permissions, but this approach gives us the huge flexibility and reliability. The next thing to deal with is encodings. If you've already seen such messages in your practice or your users seen such messages in your applications, you understand that this is a mistake. This is something wrong, this is something bad happened inside the database. How to avoid such situations? Always set encodings explicitly. Use special syntax, use special capabilities of your tools to set encodings explicitly. Never rely on default settings of the DBMS, because otherwise you'll get such messages a lot. And the same idea is applicable to storage engines. Never rely on default settings. Always set storage engines explicitly. Use syntax or use capabilities of your tool and set storage engine explicitly. Otherwise, the behavior of your DBMS is a big question. Maybe you've already created a lot of indexes on previous levels of modeling, but if you've forgotten something, add indexes here, use SQL or use your tool's capabilities and add those indexes. Then experiment and analyze if these indexes are good or not. If they are somehow bad, so you may always delete them. And the most tricky part is DB or DBMS settings. Of course, some settings may be managed through SQL queries, but for some settings you'll need some description like this text, and please pay attention to this warning. Never provide a copy of ready-to-use config. Why is that bad? Because when you have the whole configuration file, some settings are good there and some settings are not applicable for the situation when someone is using such configuration file. So this may lead to a disaster. But if you provide such a text description, you mentioned some file, some section of options in that file, some option, some value, and so on. This is impossible to copy-paste into some config file. So your colleague has to open the config file, think about it, and change something there. So all those incompatible settings will not appear in the config file. Of course, some parts of this level's results may be encapsulated into data logical model, but some require unique approaches and techniques, and we'll discuss some of them in the next video.